Welcome back. This lectures we will talk about the UML. Same as the BPMN, we cannot cover everything about the UML in this training course. In future, Visual Paradigm will release more training course on UML and different diagrams. Just get some ideas about what is UML. Even you are not a developer, it's good to know. First of all, UML. What is UML? UML stands for Unified Modeling Language. It is a language just like the language we speak, we write, we use to send messages. And the main difference of the language of UML is it is for modeling and especially for software system modeling. And the purpose of the language is same. It's for communications. The UML is for the software development team to have the same language to communicate. They can draw diagrams and then to express to his teammate what he want to do, what he want to develop. If you're speaking in a general language, that would have some problems like the ambiguities, the understanding of what you want. And maybe you are not same mother tongue, then you speak English, the other one speaking in Chinese, in French, then you don't speak, the communication doesn't run very well. So UML is for this purpose. And just brief some about UML history. UML have been there for quite a long time. From 1997, the OMG, Object Management Group, adopted UML 1.1. This is the UML actually is proposed by three amigos who work from different countries, from Sweden, US, and they work together to develop the first UML. This is 1997. And then 3 years later, UML 1.3 released, adding some more diagrams to it. And then 2001, UML 1.4. And 2005 is another big milestone. The UML 2.0 release, adding a lot of diagrams to the UML to cater for better design. You can express it more fruitful in the diagrams. And at the same year, the ISO also certified that the UML 1.4.2 become kind of ISO standard. And 2011 we have UML 2.4 have a lot of enhancement. And 2012 and ISO also validated the latest version of the UML as in part of the standard. And the Visual Paradigm implement the latest version of UML. So after releasing new release of the UML version, you can expect Visual Paradigm will follow up in the coming release, will support the new diagrams, new properties, new attributes, things like that. Why we need UML? Let's do a very classical comparisons. Software engineering is an engineering just like other discipline, just like the civil engineering, electronic engineering. And let's compare to the civil engineering. If you want to build a dog house for your dog, it's simple. You can do it by yourself, or you just employ one guy who can build a house by himself. He don't need any assistance. He can just use the nail, the jigsaw to cut the wood, stick it together, and they build a house, maybe just 1 or 2 days work. And you can do everything by yourself. Then you don't need to communicate with others. But if you build a high-rise building, a modern building, just like this one, the HSBC headquarters, then you can't do it by yourself. What you need is a team of experts. You need an architect, you need an engineer, you need different disciplines, engineer like civil engineering discipline, you need electronic engineer, you need water service. Different types of engineer, different types of expertise need to work together to deliver such modern building with a lot of facilities. And this engineer, how they communicate, they use a lot of design document we call blueprint to communicate with each others. So they know how to put the things in different time, and everything will work just seamless without any problem. This is the purpose of the blueprint. Same as the civil engineering. If you look at the software engineering, if you do a really simple applications like Hello World, maybe you also develop a calculator. You can just do it by yourself. You just coding on your PC, and then you generate the executable, and then it runs. Maybe you also develop a simple apps for your phones, for your tablet. You can do it by yourself. But if you deal with a really complicated applications like the Facebook, even as Mark Zuckerberg, you can't build the Facebook by himself. So what he needs is a team of engineers. As far as I know, Facebook has around 30,000 or 20,000 employees. Of course, not everybody is an engineer, but you can imagine that is a good percentage of the staff is an engineer. They work together to deliver Facebook such huge systems, including design, including programming, deployment, maintenance, everything. So how to do that? They need to communicate. They need to have some way to communicate effectively within the team. That's why you need UML. Then UML provide different types of diagrams that you can express your idea. You can discuss your idea. You can come up with conclusions, how to build the stuff, how to maintain the stuff. So this is the reason we need kind of design. The UML is a standard that every software engineers can interpret the same diagram in single meanings with a very, very minimal ambiguities between the author and the reader. So that's why we need a UML. So the UML is good for design a very common applications with user interface, a menu, buttons, fill in the form, and workflow applications, or even it's a very complicated applications like the airplane systems. In the airplane system, you don't have so many user interface interactions, but you have a lot of state coordinations between different sensor, different device, motors, and thermometers, etc. So you still need to have a lot of communications between the device. So the UML also helps even you're building such complicated applications. And when to use the UML, just outline some basics in some scenarios that you need UML. When you want to determine the system requirements, you need the UML. The use case is a proven approach to build a business aligned applications. All the things you put into the system should be aligned to specific role of users who will benefit on your features and describing the user goal of the users. So the use case is a good place to capture the requirements. And if you want to design the system, how to implement the system, you also need UML. Like you need the object structure, describe the object structure. Then you need the class diagrams. If you want to show the interactions between the systems, then you can employ the sequence diagram. We will have some details about the sequence diagram later on within this lecture. And if you want to re-engineering your system, you also need the UML. You need to understand what the system today, and then based on your understanding to rebuild the systems in different platform or for different technologies, something like that. And also you may need to decide the deployment architectures to roll it out in the data center, in the cloud, in anything. So in this case, the UML also can help to make sure you decide the deployment and also how to roll it out to your facilities. Okay, let's take a look about the UML structure. UML itself has around 15-16 diagrams. But basically, you can classify this diagram into three types. One is the structure diagrams, and then the behavior diagram, and the interactions diagram is for different purpose. It's similar to the civil engineering. We talk about the different types of diagram is for different usage. Just like when you're building a high-rise building, you need some floor plan for making the building. You need some electronics diagram to show the layout, the alignment of the electronics, the water surfaces, and different diagrams types for different purpose. It's same in software engineering. Let's talk about the structure diagram. The structure diagram is used to, of course, to show the structure of the things. Just this simple example. You have a shape. Under the shape, you have a rectangle. Rectangle is a kind of shapes, and square is a kind of rectangle. So it's showing the structure, and also showing the relationship. Just like we have an order, and the order have a multiple delivery, and each order have multiple order lines. Of course, you may order multiple things in single order. So this showing the relationships. And then about the behavior diagram, of course, it's showing the behavior of the system, but the behavior could be an external behavior, how to interact with the third party, with the external, and also internal behavior, how to do your work. It could be a system flow and the state, the machine to show the state. We will have a more example later on in this lecture. And then the interactions diagram. The interactions diagram, as its name, it shows the interactions between things. It could be between the systems. You may have multiple systems in your environments. You show how they interact, how they send the messages between, or the interaction within a system. You may have some key objects. You need to show how they interact to deliver the system. So the interactions diagram is very important in the UML specifications. Yes, let's wrap up what we have talked about in these lectures. We talk about what is a UML, the Unified Modeling Language, and also cover some brief history of UML. And you see it says long history from UML and also adopted from ISO. And talk about why we need UML for the purpose of communicate between the software engineer, between different disciplines. And when to use the UML, we covered the requirements. You need UML, design system, you need UML, and deployment structures. And also we talk about the structure of UML, the three category of UML diagrams. So thank you very much for attending this lecture, and see you soon in the coming lectures. Have a good day.